Hello everyone, today we will look at the new features of Neon Generator and some old fixed ones also. So let's start. Let's make geometry, call it neon, let's go inside, and now we need some curves to make our neon. I can draw some curves, but I will import them from an SVG file through the lib, import SVG. Accept, and here it is. Now I have to clean it up a bit, so let's turn on the primitives and we can enable convert Beziers to polylines, and this is what we want, and also polypath segments. And now if we look at wireframe view, we can see that every line is one primitive. Next, we want to place it in the middle of the world. So let's attach a line, axis align. Also, let's make it a more realistic scale. So it would be like 2 meters by 2 meters maximum, something like that. Now we have to split it in separate parts. So we'll use the split primitives and select the one which is the backplate. I will invert selection so that I have neon curves here, and here will be the backplate. So now I will add the neon generator. So go to SingleVector, neon generator. Now enable that. Let's disable the primitive count, and we can see that there is a little bit of chaos here. The best way of organizing it, in my opinion, is to use sort by selection node. So I will just select the primitives in their order, in the order I want. So let's start with this one. Be the next, this would be the next after that, and yeah, with the brush tool it's really easy to select them in sequence. That, all right, press enter, and now if we enable again the primitive numbers, we can see that primitives are ordered by our selection. Let's look at the neon now. This is a little bit better, but it's not perfect yet. So we can add the sequential join. Actually, I will look from the front view and enter the tool. And here I can see how the curves are connected. And also I can change the directions of these curves. So these arrows show the direction they are flowing towards. I think there are a few places that could be better, like this one, for example. And also, this could be okay. Next one, maybe we can invert this. And also the connection distance is now really large, so we can just change that. And so the connected parts will be where the distance between these curves is less than this number. So they are connected now like this. This connects there. Okay, we can invert this one. And actually this could be the opposite direction. And what if we, yeah, this one also could be like that. Now we have to choose the output original sorted and not the all. Because if we choose to output all geometry, then we get also these connections as geometry. But Neon Generator needs just the source curves, but correctly ordered. So if we choose original sorted, then you can see that these are basically the same original lines, but their order is correct. And also the vertex order is sorted correctly. Now, when we go to Neon Generator, this looks much better, but we again have these long lines. And that's because we haven't enabled the connection type here. It's now connect to all, but we can choose the attribute. And attribute is basically this name attribute which comes out of this sequential join node. So if we look at the name attribute, this node outputs name attribute based on which lines are connected. So when we see the guides, these are connected, so it will be one segment, one piece. And now it really is the same as in our sequential join node. Okay, so let's look at this in perspective. And of course, in this case, we have these letters that are hand written. We have these overlapping parts, and there are two ways we can solve that. There is automatic way and also, of course, the manual way. The manual way would be to just edit the source curves. So we could place here in the middle, maybe edit and manually offset these lines. And that is absolutely an okay way to do it. But that, of course, is more labor intensive. So we would like to do it automatically. Let's enable the Neon Generator again. And as you can see, because we have this edited curve, this actually has been changed. But let's disable that for a moment. And if we go to the Neon Tube tab here and go to the overlap depth and enable that. intersections have been found, and in most places they look quite alright. Sometimes there can be some intersections have not been found, and then you can adjust that by this proximity tolerance. In this case it works good, but sometimes you can adjust it a little bit. There is one problem with this approach, which is that we have two lines that are intersecting the same other line. And because this depth is determined by which primitive is first and which is last, then of course we have this situation here that this line is going above this one, but below this one. Easiest way to fix this would be to just offset this line exactly like I did here before. And that actually will not generate the automatic intersection there also, because those lines will be with a distance from each other, and so there will be no intersection. Let's enable this edit again, and I will just offset this edge. So on the z-axis, like that. Let's see what we have. Okay, so we maybe just need to adjust a little bit the offset here, like that. So this should be almost fine. We want to invert this part when this line goes below and this one goes above, and we can switch how these intersections are solved. So here is the option to invert that. Of course, that influences the whole sign, so you have to be aware that it's not possible to adjust just one position like we did here manually. That is something you have to be aware of. But in most situations, I think that works quite well. Now we can choose if we want bent ends or straight ends, and they can also be extended. But in this case, we want them to be bent, and I really don't like that we have too many supports now. And let's go to the supports tab, placement, and we have also the feature to place them on the beam intersections that can be defined. We haven't defined them now, so just ignore that. And let's go to these parameters, and here's the distance parameter. So we can increase the distance parameter, and that's controlling how often on one segment supports are placed. But of course, this is too much, so maybe this could be all right. And also we have this ignore curved areas enabled, which means that if we enable allowed area guides, you can see that the supports will be placed only where the green part is. And every green part is basically a separate segment which has start and end. In this case, this segment is the start and this is the end, and so we can change offset from start and end here. Looks quite good. You can increase maybe the threshold a little bit. It actually looks alright, but maybe we can snap some of them. Yeah, because depending on how long this one green segment is, you can choose whether those supports are snapped into one. And if it's still too much, then we can also delete. So for example, if we have really small segments like this, then this works really well to delete those. Okay, let's disable the area guides. Now, we also have this backplate, which we can use. I will just output it as a separate node, out backplate. Now in this neon generator, I can define this as a source for backplate. So if I go to the main tab, here we have an input geometry section, and here is the backplate SOP. So I can just drop this in here. And now when I will go to the backplate tab, enable backplate, this will use that geometry as a backplate. If I wouldn't have defined that here, for example, like that, then nothing is happening and it's throwing an error so that we know that there is no geometry. So let's enable it again. And as you can see, now our backplate is facing the other direction. So we can just reverse it. Now it's correct. And this will also work correctly now. Yes, so this is, the walls are now coming forward. All right, so next thing is that our backplate currently has quite low polygon count, especially in these sections here. And this could be all right if we need a really precise shape. But if we want to add a little bit of deformation to it, then we need a little bit more geometry. So maybe we can just resample the source lines. So 0, 2 distance, and maybe resample by polygon edge. That means that we will not lose the existing geometry, we will just add more geometry to the line. And I would say that maybe to not have too much polygons, we can actually refine it before that, unrefine to be exact. So like that, and then insert really low parameter here, and the shape doesn't change that much actually. And now we get leaner edges. This should work really well. Now we can just enable some noise here in the backplate base geometry tab. So we go to noise deform edges, enable that, which is probably too much, but because we added a little bit more polygons to the shape, we can now use the curvature mask to isolate the deformation just to the straight parts, because corners can intersect, tight corners, there could be some intersections if we apply noise to it, but if we enable the curvature mask, then that will not happen. So here we have curvature mask preview, the corners are masked, and we can control the blurring effect and the mask influence. If we increase this, then those parts get less of the noise. And also probably the frequency is too small. Let's have a little bit larger deformation, change a little bit the seed or evolution of the noise. And maybe we want to have the wall depth a little bit more, so something like that. Now, I don't really like this spot here, which is going through, and we have to think how we can solve that. And one of the ways is just to change the order of primitives. I'll just copy this one in case I need it. We can try and switch order around, so, or switch the direction and see what happens. For example, what happens if we switch this one? Nothing good. Like that. Yeah, let's separate this so that it does not connect there. All right. So now we have this part as one, and this is separate, and then this starts as a separate part. And what that means is that those parts will be connected with a cable and not with a neon tube, which probably will look better. Another place I don't think we want is this one. So we have this intersection here. So maybe we should invert that place. Probably not. Maybe this should not be changed. Yeah, this could work. Why not? Let's see. Okay, so there is also this spot, but we will correct this in another way. We can just rotate this end to another direction, and that will solve the problem. But we will not do it manually, but we have a special parameter for that. So let's enable the cables now. And if we open the base panel, then we can make them have a little bit more gravity. And maybe in this case, all this could be all right. But, and yeah, this is going through the backplate, and yeah, there is just no good way to solve that really. But we can try the snapping options though. So snap to supports, and sometimes that can solve the situation. That just means that it will not just freely hang like that. Basically, if this cable is very close to this support, we'll snap to it, or this will snap to that one, and or maybe even that one. So in that way we will have a little bit different layout of the cables. So enable that. Yeah, and as you can see, for example, this cable is going here and then here, and that just makes a little bit different visual result. If we increase the support snap distance, can create a little bit different result. Also here, cables are going that, and maybe we can just change the gravity amount a little bit or not. Yeah, this could be all right. And we also have this first and last cable end positions, and now they are set to auto, which means that this is the first position, this is the last, and so they are just hanging down. But if we disable the auto, then we get these controls, and we can change the location of these starting points of these cables. So maybe they can be more to the sides or something like that. And also we have this option here to disable the first and last cable, and also disable the only between separate segments. This is more realistic. So the power comes in, it goes through the tube, and it goes through another cable, another tube, another cable, and so on. But if we just for the visual effect want more chaos and more cables, then we can disable this option. And now every separate tube will have also cable between the start and end point. And that way we will have basically a double amount of cables. And also if we snap to supports, then of course the chaos can be even more increased like that, you know. Maybe we should change a little bit the start and strength also. This is already looking good, but we can try to increase the radius. These diameter parameters are taken from the real world, but you can also choose the custom option. Now we can adjust the scale how we want. Maybe we should change the corner radius also. And let's add a little bit more depth to the neons, just a little bit more space between the neon and the backplate. Now I would like to change the support clamp geometry from plasticky thing to the double wire, which is my favorite. And yeah, it seems like we will have to add a little bit more space to the sign still, like that, maybe because I want to also have the shafts with ridges and add a little bit bevel also. We will need to add a little bit more depth to the backplate still, like that. Maybe we can add some thickness to it, because now it doesn't have any thickness, but we have these edges which are controlled here, so we can enable them or disable them. I find it that in most cases there is just no reason to duplicate the geometry for the outer wall of the backplate. We just need this edge to have a little bit like specular reflection on it or something like that. But of course, if we want, we can enable the thickness and we can also make it backwards like that. Now we also have the option to have holes in the places where the cable or the neon is intersecting. So if we go to the backplate punch holes section, we can enable holes for cables and maybe increase the ring radius. Oh no, the scale offset. Okay, so the scale offset here, and also in the other place we will have an opening there. So if we would have an intersecting neon, then we could also enable the holes for neon tubes. There are two options for finding these intersections. Boolean is much more stable, but it can make strange results. For example, if we have a cable which goes like that, as you can see, then the whole section is cut off here. That can be partially solved with switching to intersect, but as you can see, this still doesn't really work. Oh, and also we want to correct this part here. And to correct this part, we can just go to the Neon Tubes tab. And here is the tab and rotations. This should be the last, one of the last steps in your adjustments. At least you should be sure about the order of neon tubes and how they are connected, because these parameters here will depend on how many endpoints, how many caps you have. So if I press this refresh rotation params, for every end, for every cap, a parameter is added, and it controls the rotation of that cap. One thing here is that if I change this now, nothing is happening, because we just have to let the system know that these parameters have been added. Sometimes you just need to go and change a little bit some other parameter, like here for example, and now these will be detected. So as you can see now, if I change this end is rotating around its axis, and we probably don't want to change this one. So we can just find which one is, and I know that it probably would be much easier to just have a gizmo here and just click on the cap and adjust the parameter like that, just by dragging visually. But that is something that is not implemented yet, but maybe in future. It's actually not that bad. You just change a few of these parameters and quite fast you can find the one you need. So this one is the one we want. I can just maybe rotate it in some different direction like that. And actually I think that maybe we can rotate this one a little bit to the bottom like that. All right. Now we also have these backplate connectors here, and they also have a few parameters. For example, if we go to backplate connectors, we can enable also the ignore curved areas, allowed area. Now we have a guide, which is probably easier to see from the behind. It's similar as one for neon tubes, so if we increase this, parts that are more curved will be excluded. something like that. And also we can increase the delete threshold so that we don't have too many of them. And of course we can change the shape of these and size and things like that. Sometimes if they are going through the wall, for example here, so we can just increase the distance from the wall a little bit. Let's add some colors to these. So the neon tubes maybe could be something like that. Oh yeah, and we can also add some beams to this. This could be the first version. Maybe this is neon 1. So let's make a different variation of the same thing. Okay, so this will be neon 2. Okay, and neon 2 will have no backplate. This is what we have. Of course, we need something this neon is standing on. So Bezier, and let's draw some polygon lines. And I will draw these lines the way they probably physically would be done. We want to place them so that neon can be connected to them, to these beams. So I will just draw here like that through the letters. Okay. Now let's make another one here, then another one here. This kind of makes sense, I think. As you can see, this is also on the same plane as our as all the other lines, like that. So we can now input these lines inside the neon generator in the same main tab, support beam SOP. Input this, and let's go to beams, enable beams. All right, and now we have some depth to them, some width. We can increase that, and also change the endings. Maybe we want them to be open and have some thickness to that. And now there is one problem. These supports are not in places where they can connect to these beams. And for that we need to go to supports tab, placement, and enable at beam intersections. This should solve our situation. There is one problem. These are still not aligned to the beams. So we have to snap them to the mesh. By default it's set to backplate, but we can choose the beams. And of course, there is one other thing. When you enable this at beam intersections, then sometimes you will have spots like this one, for example, where supports are maybe too close together. And in this case, there are no good controls over that, but basically have to go to the source lines and you can just move these points and that will change where the supports are placed also. Alright, you can actually make the gravity even more pronounced, something like that. I thought about adding some option to make these vertical beams to be automatically offset and not intersect with horizontal ones. I don't know if that's better or not. Maybe these are just beams welded together. Alright, maybe we should add another line here. Otherwise it just doesn't look really realistic. It can be like that also. Yeah, so this is something we can render already. Let's look at it without the wireframe. Okay, we will see how we can shade this in Solaris Karma in the next video. Thank you for watching, and I hope this system will be helpful to you. Bye!